Today we are doing trig functions of any angle, day 3, and we're going to learn about reference angles. And reference angles are, just like the name says, we refer to these angles to help us find positive acute angles formed by the terminal side of theta and the x-axis. So if you think about our unit circle, and this is 0 degrees, well, let me move it here. Here's 90 degrees. And in radians, that's pi over 2. Basically, our reference angles, when we say they are acute, that means they have to fall in the first quadrant. So anything that falls in this quadrant here is considered a reference angle. And so we refer back to these angles because they are special. So if you had to find a reference angle, you have to realize that it has to be the difference between the terminal side, that's where it lands, and the x-axis. So we're either using 0, or we should say 360 degrees, and over here 180, or pi, and this will be 2 pi, to help us find our reference angle. So for example, let's say theta was 345 degrees. Now we know that 345 degrees is not an acute angle. So what we have to do, if you think about 345 degrees, that will land in quadrant 4. So to find the reference angle, we basically need this angle right here that is formed with the terminal side and the x-axis. So the way that you can figure it out is see if this angle is closer to 360 or 180. And if you notice, it's closer to 360. So all you have to do is find this difference. So you would do 360 minus 345, which is 15 degrees. So this would be the reference angle because it's positive and it's acute. Now let's say they gave it to us in radians. Let's say theta was 5 pi over 6. So you have to figure out, is 5 pi over 6 closer to 1 pi or 2 pi? Well, to figure that out, we got to get a common denominator. If we use 1 pi, or pi over 1, we will have to multiply by 6. So that would be 6 pi over 6. But if we wanted to use 2 pi, and we multiply by 6, that'll be 12 pi over 6. So we have to figure out, is 5 pi over 6 closer to 6 pi over 6 or 12 pi over 6? So we would use that one. And you would subtract again. Which would equal 1 pi over 6, which is smaller than pi over 2. So that is an acute angle. Now, what happens if the angle they give us is negative? So if you think about it, negative 135 degrees will be in quadrant 3. So we want this angle. So is it closer to 180 or 360? Of course, it's close to 180, so we have to figure out what that difference is. So you would do 180 minus 135, and that would give us 45 degrees. So that would be the reference angle. So what you're trying to do is get an angle that is positive and it's an acute angle that's made with the x-axis, not the y-axis. And then let's do another one. Let's say it was just 2.5. Okay, so we know that pi is 3.14. We know that pi over 2 is approximately 1.57. And then we have 0 right here. So 2.5 will lie somewhere in this quadrant 2. And you might know which one is closer to, which would be 3.14. So you would subtract minus 2.5, and that'll give us 0.64 as our reference angle. Okay, so now I want you to try these 4, finding the reference angle. Okay, here are 4 for you to try. Pause the video, try them, and then we'll check our answers. Okay, for A, I know that 210 is closest to 180. So let me draw it for you. So the distance between its terminal side and the x-axis is 30 degrees. Then we have 7 pi over 4. Well, 7 pi over 4 is closer to 2 pi, which is 8 pi over 4. And I find the difference, which would be 1 pi over 4, or 45 degrees. Then part C, this was a negative angle, so I had to go to negative 240, which lies in quadrant 2. And so since we had to make it positive, I figured that negative 240 is the same as positive 120. So the difference between 120 and 180 was 60 degrees. If you notice on all these, we're getting that angle to be acute and positive. The last one was 3.6. So 3.6 had to lie in quadrant 3. And so I knew that it was going to be closer to 3.14, which is pi. And I found the difference, and that's 0.46. If you are unsure, when you find the difference, if you selected the wrong measurement, then what's going to happen is you're going to get an angle that is greater than 90 degrees, which means it's no longer acute. Okay, we're going to do more finding reference angles, but we're doing angles now that are larger than 360. So the first one we'll try is 580 degrees. So So you know with 580, when we figure this one out, and we know we have to go one full circle. We know that. So I'm going to subtract off the 360. And I will get 220. And so 220 falls in the third quadrant. And to get the reference angle, remember you have to see if it's closer to 360 or 180. So since it's this angle right here, from the terminal side to the x-axis, we're going to use 180 to find the difference. So 220 minus 180 will give us 40 degrees. So that would be our positive acute angle. Now, if they give it to you in radians and it's over 2 pi, you basically think about the same thing. So that's 8 pi over 3. And so we'll use 2 pi, but we need a common denominator. So that'll be 8 pi over 3 minus 6 pi over 3 gives us 2 pi over 3. And you know from your unit circle, 2 pi over 3 lies in the second quadrant. So to get the reference angle, we need the angle that's formed from the terminal side to the x-axis. So that is closer to pi. So we're going to find that difference. So we'll do 3 pi over 3, which is 1 pi, because I had to get a common denominator, minus 2 pi over 3 gives you 1 pi over 3, which is our positive acute angle, because pi over 3 is less than pi over 2. So to recap, that's 1 pi minus 2 pi over 3. I'm just going to show you. So I had to get a common denominator. That's how I got 3 pi over 3. And then the same if it's a negative. See, with negative 13 pi over 6, remember if it's negative, you're going to add 2 pi. And you'll get a common denominator. And you're going to notice that just doing one rotation or one revolution is not enough because we're still in the negative. So that means we have to do it again. Which would be negative 1 pi over 6 plus 12 pi over 6 gives us 11 pi over 6. And 11 pi over 6, if you remember, falls in the fourth quadrant. So to get our reference angle, we need the angle that's formed from the terminal side to the x-axis. So now this one is closer to 2 pi. So you're going to do 2 pi, which we already found was 12 pi over 6, minus 11 pi over 6 which gives you 1 pi over 6, which is an acute angle. So sometimes you have to keep adding until you get it positive, or get it under 90 degrees. And if it's in radians, that means it's pi over 2. In our previous section, we used our special right triangles to evaluate exact values. So we're going to do a similar process, or use a similar process. Here's 30, 60, 90. Remember, that's 1 square root of 3 and 2. And here's my 45, 90. So that's 1 square root of 2. And we know that 30, 45, and 60 are special angles, which are located in quadrant 1. And in radians, those are power 6, power 4, and power 3. Now, get your unit circle out, because we're going to fill in the coordinates that go with these special reference angles. Okay, remember I said that we have X, Y, and R. Remember, X represented cosine of theta. Y was sine of theta. And the special thing about this, we can find tangent. Remember, tangent is sine over cosine. Or y over x. So if we're talking about the 30 degrees, let's fill in that one first. You go to your 30-degree triangle and you find cosine of 30. So that would be adjacent over hypotenuse. So that's your x. And then sine of 30 is opposite over hypotenuse. And then using the 45, go to the 45, 90 triangle. Cosine of 45 would be 1 over square root of 2, but you have to rationalize it. So that'll be square root of 2 over 2. And then sine of 45 is the same exact ratio, because then you have two sides that are the same, because it's an isosceles triangle. So it is also square root of 2 over 2. And then cosine of 60 would be adjacent over hypotenuse. And sine of 60 would be square root of 3 over 2, which is opposite over hypotenuse. So those are the coordinates. And the good thing about these, the 30, the 45, the 60, these are reference angles that we're going to use to help us find exact values of any of the other angles or degrees or radians in our other 3 quadrants. So for example, here we have sine 135. So, 135 degrees falls in quadrant 2. The reference angle that goes with that, remember, would be 180 minus 135. And then that would give us 45 degrees. So remember, we already have that with our, if you fill it in your coordinates. So we're basically finding sine of 45. And you also want to remember ASTC to see if it's going to be positive or negative. So sine is positive in that quadrant, so we're good. So when you do sine of 45 degrees, which we already have from quadrant 1, we know that it is the square root of 2 over 2. And in quadrant 2 is positive, so we're good. Okay, in radians, we have cosine 4 pi over 3. And we know that 4 pi over 3 lies in quadrant 3. So we need this reference angle, which is closer to pi. So you're going to do 1. And you know that if you had to get the common denominator, you'll have 3 pi over 3. So to find that difference, you know, or distance, and it can't be negative, so I'll put the larger number first. We get 1 pi over 3. And we already know from quadrant 1, cosine of pi over 3 is 1/2. And you always got to check A, S, T, C. But see, in quadrant 3, cosine has to be negative. So you got to make sure you make it negative. And then the last one, cotangent of negative pi over 3. Well, you know negative pi over 3 means we are going in this direction, which is going to land us in quadrant 4. And so pi over 3 is already a reference angle. It's already acute. So when you find this distance, we're going to use 0. Then you're just going to get pi over 3 as the reference angle. So we're doing cotangent of positive pi over 3. And we already have that the reference angles in the first quadrant. And what we didn't do is do the tangent values for those. So let me show you those really quick. Remember, this was pi over 6, pi over 4, pi over 3. This was square root of 3, 2 over 1/2, square root of 2 over 2. And this was 1/2, square root of 3 over 2. So to find tangent, remember tangent of theta would be y over x. So if you go to pi over 3 and do y over x, you're taking your y and you're dividing it by your x, which is the same thing as multiplying by the reciprocal. So those cancel, and you get the square root of 3. So that's tangent. We need cotangent. So that means that you have to do the reciprocal, which is 1 over square root of 3. Don't forget to rationalize. So that's the square root of 3 over 3. Now we have to check to see if it should be positive or negative. Remember, we're in quadrant 4. A, S, T, C. So only cosine and secant are positive. So that means cotangent has to be negative. And there you have it. If by chance you have a number that's bigger than 2 pi again, you're going to do the same thing where you may have to keep subtracting to find the reference angle. So if you had like tangent 14 pi over 3, you know that is larger than 2 pi. So you may have to keep subtracting 2 pi until you get it. Because here our common denominator is 3, which means we're going to have 14 pi over 3 minus 6 pi over 3 will give us 8 pi over 3. That's still not small enough. So we're going to take away 2 pi again. And now we have 2 pi over 3. Remember, 2 pi over 3 falls in quadrant 2. So we need this difference between this terminal side and the x-axis, which is pi. So that's 1 pi over 1, getting it in common denominator. That's 3 pi over 3. So you have 3 pi over 3 minus 2 pi over 3 gives us 1 pi over 3. Don't forget to do A, S, T, C. So we're actually finding tangent of pi over 3. And we know from our first quadrant we have that. Actually, we just found it, which was the square root of 3. And since we are in quadrant 2, tangent is negative. And that would be your answer. And then remember, if it's negative, you have to keep adding 2 pi until you get a positive acute angle, which is our reference angle. And same thing if it's in degrees, you want to make sure you keep subtracting 360 until you get it to a reference angle.